Okay, so we're trying to figure out common ion effect, all right? And all right, the best way, I think, is to look at a problem. If I had a solution, all right, I've got a sodium iodine solution, and I combined it with a lead iodine solution, and these are both saturated, all right? You'll notice that they both share a common anion, all right? The common ion effect, all right? And this is particularly important if one of these solutes is highly insoluble or an insoluble salt, something that has a KSP value. So if we look at these two things, we're going to find out that the sodium is highly soluble. There's 1.4 kilograms, 1.8 kilograms, or close to 2 kilograms per kilogram of water. That's a liter. Whereas the lead isn't very soluble. It has a KSP value, all right? And that's 9.8 times 10 to the negative ninth. So when I mix them, what's going to happen, all right? What would happen to them? And I didn't add the solid. That's what this common ion effect is about. So here's I take a solution with an insoluble salt and I add it to it. Depending upon your concentrations of your insoluble salt, the original solution, and your common ion, then you would have precipitation. All right? Or I shouldn't say you would, you could. All right? If you look back at the original problem, here's the key giveaway that there definitely would be precipitation is because they're saturated. All right? And in this case, there's going to be so much iodide ions in the solution that some of this is going to be precipitated out. By some of this, I mean some lead iodine is going to precipitate out. All right, I want to explain this with shapes. You've got a lead iodine solution. Lead iodide is not soluble, so very little is going to enter the solution. All right? Very, very little. Then, now I'm going to dump in my sodium iodide solution, but sodium and iodine is highly soluble, so like there's going to be tons of these things. And the sodium I'm going to leave out because the sodium is kind of like a spectator ion in this. Now, when I flood this market with lots of iodide, there is only a little bit of this lead iodide would want it to be dissolved or should be dissolved in reference to its KSP value. Therefore, when I flood, I kind of take up the room of these, and that was why it would precipitate it out. I'm kind of like taking up any space that would have been there by these common ions. All right? So when you have an insoluble salt that's dissolved and you add a common ion, you could cause precipitation, all right? Because you're taking up any space that the solution has for that weak, that not very soluble salt. Now what we're going to do is we're going to look at what happens if I try to dissolve an insoluble salt in a solution that has this ion in it. We'll look at the shapes first. Okay, here we go. Here's my insoluble salt, this green and orange one, and here's my solution, right there. It's got this ion. There's a spectator ion that's not shown, all right? We'll call it yellow. Once again, sodium, all right? I'm going to leave it out just because I don't have a ton of space. Here's my solution. If I try to dissolve highly insoluble salt or an insoluble salt in this solution, what will the common ion do? All right, the word is, I'm going to move this over. The solution doesn't have a lot of space for these things, so it's going to suppress the dissolution of this insoluble salt. All right? Okay, we've got lead iodide. I'm just going to talk it through on paper. If I put that in just water, some will dissolve. All right? Not a lot, but some, because it does have a KSP value. Okay, so some's going to dissolve. All right? But if I put that into a solution with a common ion, this could be a solution like sodium iodide, the iodide in the solution. It could be potassium iodide. Or you could do, this is lead acetate, all right, 2,4H4O. Lead acetate is a lead compound that's kind of soluble. What you're going to do is you're going to suppress this solution or the dissolving of this lead iodine. Less will dissolve, all right? The common ion suppresses the dissolution or the dissolving, etc. All right?